So I hope we are on the same page as we resume our class, that semester, and prepare ourselves for the second, and then third, and then fourth exam. Any question that you have, any problem that you have with the class, okay, please deal it with me, not with other people. Okay, we're just going to make the situation worse. Okay, am I clear? Nagkakaintindihan ba tayo? That's why I put the group chat that you have there. So if you have any problem, it's easier for you to let me know. Okay. So what I'm going to do is I'm going to go over the material that we have here. Okay. So this is just a review. Now I'm going to post the last meeting that we have where it was recorded. I'm going to post it later on. Okay. But we're going to go with this one because after today, we're going to go with chapter 6. So we're going to do chapter 6 on Thursday and Tuesday there. And then we're going to do a review of chapter or module 4 and module 5. So I might give you a quiz by the weekend because I try to make sure you gain momentum, hindi yung agad-agad quiz agad. Okay? And I hope you can put your feedback or comments on that discussion forum para at least magkaintindihan tayo. Klaro ba? Is it clear?
Yes po.
So if we're going to look at the module that we have, so based on the module that we have here, I connected it on 3 of my lectures that is related to this, what we call thermodynamics. Okay, so the topic is all about the thermodynamics. So thermodynamics usually it encompasses different what we call topics. But if we're going to look at what you really need to learn, you just have to look at the so-called learning outcome. So this is the guide that you need to follow. Okay, so what does it mean? At the end of the module, this is the thing that you need to know. So you define the energy and then enumerate the different forms. So energy is what? The capacity to do work. Okay. And then the different forms, you can have the kinetic energy, which is the energy in motion, potential energy. Okay. If I'm not mistaken, we did some introduction to it last meeting. So this is the slide that we have discussed last time. So I hope you could see the chart or the slide. So energy is just the capacity to do work, and then we have the different forms of energy aside from the potential and the kinetic energy. So we have the radiant energy, the thermal energy, the chemical energy, the nuclear energy, and the potential energy. Okay, so I usually look at the learning outcomes on how I prepare my student to do the learning. Okay, we're not here to prepare for the exam. Okay, I am here to make sure you know the information or the concept that is going to discuss in the exam. Okay, so one thing that you have to know here is the so-called thermochemical equation. Now differentiate between exothermic and endothermic reaction. So describe the first and the second law of thermodynamics and assess their impacts on the problems of the society. Describe gives free energy and predict the spontaneity during the thermodynamic quantities, and then describes the changes of state, the energy changes that accompany them, and interpret phase diagram. So we're going to discuss all problems today, as I promised to you last meeting. Okay, so if we're going to look at the so-called thermochemical equation, so we're just writing the equations in terms of energy. So if we're going to go back to the definition of chemistry, okay, usually what's the simplest definition of chemistry? Anyone? Ano yung pinaka-simplest na definition natin of chemistry? Anyone? That is the science of matter and the changes that it undergo. Okay, so usually it's the study of matter and its property, or the simplest definition is the science of matter. If you want to expand it, and the changes it undergo. Now, what are the changes that it undergoes? So usually it involves energy. Okay, so when it involves energy, so there are two forms. Either what? The energy is added to the surroundings, where you have the endothermic reaction, or the energy that is what? Released by the surroundings, or released by the system to the surroundings, where you have an exothermic energy. Is there an issue what is an endo and exothermic? Class? Is there an issue what is an endo and what is an exo? Yung iba,
Wala po.
kasi iba walang tanong, tapos mamaya magrereklamo na lang. Okay lang kung sa akin magreklamo. Okay, so whenever we have this so-called exo and endothermic, so just as a review, so you can differentiate the two of them. So if it's endo, so usually the energy enters the system. There is what we call absorption of energy. Okay, and in terms of a reaction, energy is in the reactant side. In terms of delta H, which is the enthalpy, it is positive. Okay, now if you have exothermic, the energy exit the system. And there's what we call the release of energy by the system to the surrounding. Okay, and energy is in the product side. And the delta H that you have there is a negative. Are we clear on that? You might be asked question or true or false question on this one? Class, pwedeng magtanong. Libre ang magtanong. So question. At least sa endo at sa exo. May tanong kayo?
Ano po, sir?
Yeah, sure. Pwede kayo magtanong. You can always what we call put the question in the chat box. Tanong?
Sir,
Because-
ako po.
Okay, question?
Sir, ano po, yung medyo may nabasa lang po ako dun sa resource material natin naka-attach. Sir, yung medyo hindi ko lang po magets yung sa about what the energy diagrams po ng endothermic at exothermic reaction po.
So yung energy diagram.
Apa, sir. Sir, pwede pong pa-explain lang
Yeah,
po.
yeah,
Medyo confusing po
walang
ako.
problema. Okay?
Okay po, thank you,
So
sir.
usually, ang makikita mo doon sa endo tsaka sa exo, if you're going to draw them, so meron kang, nasaan na yung ano ko? So ano to? Teka. Usually isa ganyan, tapos yung isa ganito, di ba? You follow? So alin dyan
Apat,
yung
sir.
exo, alin dyan yung endo?
Sir, yung endo po is yung nasa taas po. Tapos yung
Y- y-
exo po ay nasa baba po.
Because if you're going to look at this is your
Product po.
delta
Ay,
E.
reactivation energy.
So this is the reactant and this is the product. This is the reactant side and this is what we call the product. So as you're going to look at here, okay, the product has a higher energy compared to the reactant. So how are you going to do that? How are you going to go there? You're going to need additional energy. We're not talking about activation energy. Activation energy that we have here is this. It's just that the energy difference. Okay? So if you're going to look at here, which is more stable? The reactant or the product? Hello? Alin yung stable? So usually when you're talking about stability, that's the one that has lower energy. Okay? But the thing is, you need a reaction to produce a product. Now, unfortunately, the product is what? It has higher energy. So how are you going to go there? You have to add energy. Kaya yan yung tinatawag na endothermic. Because you need this amount of energy to get from the reactant to the product. Now, unlike here, which is more stable. So we could say this is your endo. Now, unlike here, this is your exo. So the one stable here is the product. Okay? So it's easier for the reactant to go to the product because the amount that you have there, okay, is you're going from a situation where if there's lower stability going to higher stability. And how do you do that? You're going to release energy. So the delta E that you have here, that is a negative, okay, compared to the one that we have here. This is what we call a positive. So this is the energy that you need to go from the reactant to product. Here, this is the energy that you release while going from the reactant to the product. Is that clear? Class?
Yes po, sir. Medyo na-confuse lang po ako dun sa
No, it's fine.
notion.
Walang
Medyo
problema.
na-confuse lang po ako sa notion, sir, na yung resource, nakastate po kasi sa resource po na reactants have higher bond energy or stronger bonds than the products. Tapos may sunod po na strong bonds have lower potential energy. Doon lang po ako na-confuse. Pero nung in-explain niyo po, sir, medyo na-clear na naman po. Thank you
And
po.
I think another thing that you can look at here is dito sa isang material kung ito. So this is where you introduce the enthalpy, yung energy na difference doon. That's really the enthalpy. Because it's just a heat flow. So heat is just a form of energy. Okay? Because energy is two forms. Ano yung two forms ng energy? Heat and what's the other one? Ano yung two forms ng energy natin? Heat and work. Okay? So if you're going to look at the process here, so the heat is given up or absorbed during a given reaction. So it depends kung ano yung nangyari. Okay? So when you have in this situation, when you have what? Solid going to liquid. So if you're going to look at here, liquid is what? At a higher energy or higher enthalpy compared to the liquid. So in that case, you need energy to be absorbed. Okay? So when energy is absorbed, it will break the intermolecular forces of attraction that hold the solid together to become liquid. Okay? And if you're going to look at this in terms of the enthalpy of the products, okay, usually it is less than the enthalpy of the reactants. Kaya nakikita niyo yung ganito. Okay, so this is your reactants. This is your what we call products. So mas mataas yung position, okay, or yung enthalpy ng products kaysa doon sa reactants. Okay, so that's why you need the energy to be entering or absorbed by the system. Now, unlike the other one, okay, the energy of your reactants is much higher compared to your what we call products. So going from here, okay, so this is the delta H of your reactants is always higher than the delta H of the reactant. So what you do is the heat is going to be given up to the surrounding. So i-ano nyo na lang ito. There's something that's confusing here. So here, what it means here, if you're going to get the difference between the two, okay, your delta H, kasi ang ano kasi dito, if you're going to look at the difference, H products minus H reactants. So that should be a positive delta H. Okay, now this one, the same thing, delta H of the products minus the delta H of the reactant, but which one is bigger here? Since the one that is bigger is the reactant, so you're going to get a negative delta H. So clear ba yun? Class?
Yes po.
Module 5 is we could say an abstract concept. So this is really hard to understand. Okay, and then when you have the thermochemical equation, so here You can ask the question, is your delta H negative or positive? So since the systems absorb heat, it's endothermic, so your delta H is positive. And if you're going to look at what we call the thermochemical equation, this is just the balanced chemical equation and the energy cost for that reaction. So for instance, this is a complete thermochemical equation. Now, if I'm going to make this 2 and 2, what will happen to the delta H? Or if I ask the question, if you have 2 moles of ice, how much energy do you need? Or what enthalpy do you need? Hello? You multiply it also by 2 because this is what we call an extensive properties. It depends on the amount. Okay, now your thermochemical equation can be like this. Okay, it can be simplest form. Well, it depends. Yun yung pagkaiba ng thermochemical equation compared to the balanced chemical equation. The balanced chemical equation is always what? At the simplest whole number ratio of the reactants and product, but a thermochemical equation can be the simplest whole number or whatever multiple you're going to multiply, whatever number you're going to multiply in the reaction, you just multiply on that one. Now, if I reverse the reaction, what will happen? Anong mangyayari kapag na-reverse ko yung reaction na ganun? What is delta H?
Negative po.
Okay, so you reverse the reaction. This one is what we call negative. So the interpretation that you have here, you absorb energy. Here, you release energy. Is that clear? I think I have it on the other. Medyo choppy. So if I reverse the reaction like this one, okay, so the system gives off heat, the surroundings gain the heat, so it's exothermic. So if I have it like this one, so as you're going to look at here, I could interpret this 890.4 per moles of the methane that is burned, okay, or per moles of the CO2 that was produced. Now, if I multiply this by 2, okay, that number will also be multiplied by 2. So the more important thing here is you're going to what we call be able to write the thermochemical equation. If I'm not mistaken, I included some sample calculation in my recorded lecture. Napanood nyo ba yun? Pinapanood nyo ba yun, class? Are you watching the recorded lecture that I have? Based on the numbers,
Yes po.
I saw that the number of views increases, so that means you're watching it. I know it's long, but you can always chop it. Let's say 10 minutes muna, ito muna panoorin ko, and then after some time, 10 minutes ulit. So this is how the thermochemical equation would look like. Now, what if I have a question like this? Ilalagay ko sa chat, okay? So what can you say about the statement that you have there? Kasi yan yung mga tipong question na i-ask sa inyo. Now, it could be what we call the which of the following statement are true. Okay? So, bibigyan kayo ng ilang statement dyan, and then you identify which of them is true. So, the way you're going to do is you're going to look at one by one. So, state function, if you're going to recall, it just look on the final and initial position, irregardless on the path that it took. I think I have what we call this one. Properties that are determined by the state of the system regardless of how that condition was achieved. Okay, so energy is what we call a state function. So ano ba yung nakalagay doon sa ano natin? Sa chat. Internal energy is a state function. So that's true. Okay. Now, how about the change in enthalpy? Is it an intensive property? That's false. Because I just mentioned it is an extensive property. It depends on the amount. Okay. And then enthalpy is the heat content of a particular system at a constant pressure. Is that true? Anyone? Totoo ba yun? Enthalpy is the heat content of a particular system at a constant pressure. So, I'm not sure if we have tackled it, but there is a system where, nasaan na yun? When delta H at constant pressure, that is also the heat that you have. I'm trying to find where is that. Yeah, I think it's here. Sa enthalpy here. See that? So at constant pressure, you have delta H there. This one. Okay. So at constant pressure, your heat there, that is your enthalpy. So we could say that is what we call also true. So if ever you have questioned that, yung true dyan pareho ay yung first and third statement. Okay, so those are the type of question that you may encounter in the second exam. So sa tingin nyo, kaya? So maybe this weekend you start reviewing again to prepare for your exam 2. That's why we're meeting here, so that to make sure you're prepared. Hindi na naman akong papayag na I don't do my part to prepare you for the exam. Because ang maaaring tanong dyan, so ibibigay sa inyo 1, 2, 3, and then 1 only, 2 and 3, 3 only, 1 and 2, 2 only. Now, kung walang choice na 2, ano ba yan, 1 and 3, so you only go with the one that give you in the answer. So maybe 2 only. Okay. So, question so far. If we're going to look at the what we call module, because I just want to make sure na meet natin yung learning outcomes ng module. So we already get the first one, the second one, and the third one. So the next that we have is the first and the second law. First law is just about what? What is the first law all about? Enthalpy, the delta H. The first law is the law of conservation of energy. Energy cannot be created nor destroyed. It can only be transformed from one form or another. Okay? And then you can go here. Pinupuntahan nyo ba yung mga materials dito? Ayaw ko. Mag-i-input na naman doon. Okay? So usually, the main thing that they do is the so-called LibreText. Like this one. This is the main material that the department use. So to know the key features of a state function, so pagpunta mo doon sa LibreText, so you have some example here. If you have a hard time understanding my lecture, you can always go to this material, and it's very useful. They have some sample calculation there that will guide you. Okay, and the solution. Have you using this class? Andiyan pa ba kayo? So those are some of the state calculation that we have here. Okay, and most of the materials that we have is connected in this thing. Okay. So if we're talking about the first law, let's see if we can go to the LibreText here on this what we call first law. So if we're going to go here, so this is the first law of thermodynamics. That's the next one. Calculate changes in internal energy. So the system plus the surroundings is equals to the universe. So we discussed about this. The heat flow is always what? From hot to cold object. That's why you call it heat. Okay. So some calculation that you may have there in the first law of thermodynamics is, I would say this one. So a sample of an ideal gas allowed to expand from initial volume of 0.2 to a final volume of 3.5 against a constant external pressure of 0.995. So at the same time, 117 joules of heat is transferred from the surroundings to the gas. So what is the total energy of the gas in joules? Anyone? So how do we solve it? So you might ask yourself, what's the formula that we're going to use? So this is just this. Now the question, okay, what are the value that we're going to use? So ano yung delta H mo dun? Yung heat. So what 17 is? Positive or negative? Okay, so it is here transferred from the surroundings to the gas. So that means the system gain, right? So if you're going to look at this, the delta H here would be positive. Why? Because it is coming from the surroundings to the system. So when the system gain heat, okay, that is a positive Q, which is a positive delta H. Okay? Now, when the system give up the heat, it goes to the surrounding, so the delta H is negative. Kasi iba-iba yung sagot nyo eh. May positive, may negative. But if you're going to look at the notes, okay, what does the note tells us? By convention, heat flow and work have a negative sign when energy is transferred from a system to its surroundings and vice versa. So if you're going to look at this, the heat is transferred from the surroundings to the gas. The gas is your system. So everyone agree that the delta H here is positive? Dun sa nag-answer ng negative? Kay Matt? So you know it is a positive because it is what we call surroundings going to the system. Positive lang, negative lang siya kapag from the system going to the surroundings. Now, the next question that we have here, what is the work? Work is in the form of, if you're going to look at here, so from 0.20 to 3.5. Okay? So if you're going to look at this, so the delta B that you have is from 3.5 to, or from point, just want to make sure, okay? From 0.2 to 3.5. So that means this is the final and this is what we call the initial. So there is what we call an expansion. Okay? So whenever there is an expansion, what does it mean? Kapag meron kang expansion, okay, anong ibig sabihin doon sa delta B? Is it positive or negative? So if you have an expansion, that's a positive. Okay? Kasi ang nangyari, nadagdagan yung ano mo volume mo. But if you're going to look what is in effect, you're going to multiply that with pressure. And the pressure is even there. Okay, so whatever you have here, so what's that? 3.3 times the pressure. And you're going to subtract it with the delta H. So kapag may expansion, sino ang nag-work? Yung system or your surrounding? Yan yung mga tanong eh. At yan yung mga nakakalitong tanong. At yan yung pwedeng sabihin na itatanong sa inyo sa exam. So you have to what we call make sure about it. So here, this is where I want you to look at the situation that we have. Okay? So yung nangyayari sa atin ngayon ay ito. So this is what? This is the 0.2 and then 3.5. So as you're going to look at here, okay, ano yung value ng W? Is it positive or negative? Yan, magkaiba na naman yung mga sagot nyo. So whenever there is what we call work, I'm trying to see if may explanation siya dito about that. Para at least I can convince you the right what the right answer is. Excuse me. Tingnan ko lang. Gas expansion. Here, I think it's this one. So the negative sign associated with pressure times volume work done indicates that the system loses energy when the volume increases. That is, an expanding gas does work on its surrounding, while a gas that is compressed has work done on it by the surrounding. So, an expanding one, ang nagwo-work ay what? System. And an expanding one would have a negative sign. Okay? Now, a compressed one, the work is done on it. Ang nagwo-work ay yung surroundings. And when that happens, it will be a positive one. So, ang nagkaano ng sign sa kanya ay yun ito. Work is defined as pressure times delta B. So, kailan magiging positive ito? Kapag negative yung delta B. And when that only happens when you have compression. When you have expansion, this is a positive times negative. So, you will have a negative sign there. Are we good on that? And I can tell you, this is where they're going to hammer you about this concept. So it's either you understand it, there's no chance for confusion here. Kasi kapag hindi ka sure, ano yun, -2, -4, -3. So it's really, we could say, hard. Okay? So question. So the thing that we have in the first law of thermodynamics is mostly on enthalpy. Okay. So here, I think we answered it last time. So the sigma, the sign of the delta H, so you know, endo is positive always, exothermic is negative. Here is absorbed, and then this one is released. So the surroundings get, we could say, cold. If it's an endothermic, the surrounding gets hot. And the energy of the product is what? Okay, for the endothermic, it's higher. For exothermic, is lower than the reactant. Now, let's go with Hess law. Okay, So maybe we can use the problem that we have here. So if you're going to look at the Hess law, it's just like a summation of different reaction, okay? And when you summarize the different reaction, or when you add all these what we call reaction, the delta H is just equals also to the sum of all the reactions that you have. Yeah, so for clarification, expansion of expansion of gas work is negative. Okay, compression of gas work is positive. We go on the definition of nasa na yun? Kailan para sigurado. What's that? We go on the definition that work is equals to negative P delta B. Okay. So when there is a gas expansion, so this is a positive times negative, so the work is negative. When this is compression, so this is what? Negative times negative will give you positive. Klaro tayo doon? So Hess law. So let's try to work on the problem that we have here. So what we're going to do is we're going to add the reactions that we have here. So I'm going to write them down para makita ninyo kung paano masosolve, because I think there is one problem about this thing. So I'm going to write everything. So you have what? C6 H4OH producing C6H4O2 plus 2H2. And the delta H that you have there, I'll just put the delta H here. So this is what? Plus 177.4 kilojoules. And then H2, no, only H2, not H2O. Plus O2 producing H2O2. Okay, so this is what? 191.2. And then this is H2 plus 1/2 O2. And this will produce H2O. So this is negative 241.8. And then you have what? H2O gas over this one. So this is delta H of 43.8. So what is the overall reaction that you need to have? So you need a C6H4OH2 plus H2O2 producing C6H4O2 plus 2H2O. So what do you need to do? You need to what? Reverse this, right? And what else? This is a liquid. This is a gas, okay? Ano pa? When you're doing Hess law, you try to add all the reactions by reversing it, by multiplying with a number, okay, and then add it together. And then which one we're going to multiply? The second one, the fourth one. So if you multiply this by 2, so this becomes times 2, and this one becomes what? Positive. So the way that we're going to do is we cancel out everything that can be canceled. So this one has already become H2O2. So tanggalin natin to, producing H2 gas and O2 gas. Okay. So which one can we cancel out? Is there anything that we need to multiply? Can we multiply also the third one? Because right now, the only one that I can cancel, I cannot even cancel this because there's only one here and there's two here. So you think we multiply the third one also? So if you do that, so this will become 2. So this will become 1 and this becomes 2. And that we can cancel this. So don't forget that we multiply this by 2. What else can we cancel? We can cancel the oxygen here. And then tama ba? So we have 2 here, C6H4, H2O2. So wala na to kasi yan na natin. And then this one. But meron tayong naiwan na to. It's either, let's try to do the number. 177.4 plus 191.2 minus 241.8 times 2 minus 43.8 times 2. Yep, so I think there's an error, I think, here. I think this is just an H2, right? Not a 2H2. Do you obey? Do you obey? Do you follow? Sama na ng wording ko. I think this is just an H2. You know why? Look at here. So O2, so that's O2 and then H2. So it's not really 2H2. So if this is H2 and then you have H2 there, so you have 2H2, so that will cancel out. Because when I get this one, I get a negative 202.6. Try. Now, you follow? Are you still there? So I think there's a grammatical error, a spelling error there. Okay, so if you're going to look at the module, I think this should be, oh yeah, it's really, ako pala nagkamali. Tama ba? Oh, the old one. Okay, I don't know kung makita nyo. It's my fault. Okay, tama. So if you're going to look at here, what we're going to do? Okay, we reverse the second one. So yung H2O2 magiging reactant, tapos yung H2O2 magiging product. So this will become positive. And then we multiply the third and the fourth by 2. and you multiply everything here by 2. Okay, so when you add all of them, so 177.4 plus 191.2 minus 241.8 times 2 minus 43.8 times 2, and you're going to get the negative 202.6. Okay? So ako yung nagkamali. Ang original ano pala, because I think this is one of the correction that I have. It's really an H2, not a 2H2. Okay? So that's how one of the problem may end up in your second exam. Okay, Rex, nakuha mo? So if you do what we call the canceling here, so you have an H2 here, so you multiply this one by 2. So, ulitin ko na lang. So originally, this is like this. And this one is H2 plus 1/2 of O2 producing H2O. And this one is H2O producing H2O. So that's liquid, and this is what? Gas. So if you're going to look what will happen, we need it to be in that form. So we transform this. We multiply this by 2. And also this one. So we cancel this. We cancel this. So one H here and another H here. Okay. And then there's one oxygen here, O2, and one O2 here. So what is left is this one. Okay. And then the H2O2 that is here. And then the C6H4O2. And then this one. Kita nyo ba yung sinusulat ko? Class? Teka. Na ano yata ako. Teka lang. Ito. Ito, kita nyo? So, kita nyo na yung mga kinancel ko?
Yes, sir.
So, okay na? That's a classic Hess law example. And I have a more thorough discussion doon sa lecture ko, sa recorded lecture. That's why I told you, you can survive if you watch the lecture. Your main enemy here is not me, it's you. You don't want me to be included in your enemy. Mas mahihirapan kayo sa course. So the next thing that we're going to talk about okay, yung second law of thermodynamics. The second law of thermodynamics is on the other hand about entropy. Okay, so when you're talking about entropy, that is the degree of disorderliness, yung delta S. So I can give you a reaction here. So what can you say about H2O gas to H2O liquid? Does it become more ordered or more disordered? What is the delta S of that? Will it be positive or negative delta S? Kasi pwede kayong tanungin dito, this is what? True or false? This reaction is exothermic or this reaction is endothermic. Okay? Pwede rin kayong tanungin, this reaction is results in increase in orderliness or this reaction increase in disorderliness. So this reaction increase in ordered. So what is the delta S of this? Is it positive or negative? Anong delta S nitong reaction na to? Okay? So, since it becomes more ordered, the delta S is negative. Okay? The delta S is positive, it becomes more disordered. Okay? So, you have to what we call, look at the notes here. Delta S, okay, where it is positive, it is an ordered state to disordered state. Delta S, where it is negative, it is a disordered state to ordered state. So what do we have here? From gas going to liquid. Okay, from a more disordered to an ordered state. So your delta S is negative. Clear? So entropy is what we call delta S. So ang tanong sa inyo dyan, ano yung value ng delta S nyo? So it is from more disordered to a more ordered. So that is a negative value. Okay. If it's the other way around, liquid to gas, then that is a positive delta S. Okay. Because the entropy of the universe is increasing. So if you're going to look at this one, so from solid going to liquid, your delta S is positive. But from liquid to solid, your delta S is negative. So what we have there is we have a gas going to liquid, so your delta S is negative. So this should be a sure points for you. Okay. So delta H, what? Energy in the enter the system, delta H negative, energy goes out or exit the system. Delta S, positive is more disordered, negative is more ordered or less disorder. Clear ba? So this is what? Enter the system. Negative or exo, energy exit system. Now, in terms of delta S, if it's positive, that's more disordered. And negative, it's more ordered or less disordered. So these are simple things that when you take the exam, when you are not understand the concept, it can really cost you. Okay, now what is the next one that we have there? Delta G. Delta G has something to do with what we call free energy. Okay, so this is what we have so far. So when we're talking about delta G, it has something to do with whether the reaction is spontaneous or not. So paano naman yan? So pag negative, the reaction is spontaneous. Pag positive, it is non-spontaneous. And if I'm not mistaken, I asked you a question last time. Failing an exam is a spontaneous process. What can you say? Is failing an exam a spontaneous process? The answer is true. Kasi wala kang gagawin. And most likely, okay, you're going to fail. If you don't do anything, okay, so you're going to have a bad grade. That's why failing an exam is a spontaneous process. What do you, if you're going to look at the definition, ano yung definition natin ng spontaneous reaction or spontaneous process? So you can understand the question that failing an exam is a spontaneous process. What is a spontaneous process? Anyone? Spontaneous process is a process that happens on its own without outside intervention. So some reaction happens spontaneously, right? If you have an ice, you put it at room temperature, what will happen spontaneously? It will melt, okay? Do you need any outside intervention there? None, right? So that is a spontaneous process. So if you have water, you put it at room temperature, will it freeze on its own? Yeah? No. So you cannot, what we call happen spontaneously, because usually a forward reaction that is spontaneous is, but backward reaction is non-spontaneous. Okay, so for instance, what will happen if I throw this pen? Spontaneously, it will be what? It falls. Okay, now what's the reverse of that? Can I make the pen go back to my hand? Well, unless I'm a Jedi, I can do that, but I don't have the force, and there's no such thing as the force. So there's an outside intervention going that is needed for the pen to go back to my hand. Do you get the definition there? That's why failing an exam is a spontaneous process. Bakit? Ano ba gagawin mo kapag hindi ka nag-aral? Hindi ka nakikinig, puro ka reklamo. Oh, hindi ako nagtuturo si Dr. Mojica kasi inaantok na po. Oh. Eh, hindi ka naman nagbasa ng module, hindi ka nanood ng recorded lecture. So there's no outside intervention. So that's what we call, what will happen if there's no outside intervention is spontaneously, you will fail the exam. Do you get the meaning? Yeah? You don't do anything. So what will happen? You didn't study, you didn't watch the video. Do you think you will pass? So what will happen spontaneously? That's the definition of a spontaneous reaction. It happens on its own without outside intervention. So that is the Gibbs free energy, which is just a combination of enthalpy and entropy. Kasi nakita nila, in terms of enthalpy, there are some reaction that are spontaneous, both endothermic and exothermic reaction. Like you put the ice at room temperature, it will become water. That's an endothermic reaction. Okay. Now, if you're going to burn some fuel, okay, it will happen spontaneously. That is also an exothermic reaction. So, hindi makapag yung predict kung delta H lang. But what they observe, whenever there's a spontaneous reaction, there's always an increase in disorderliness, the delta S. Okay? So if you look at the disorderliness, when the ice becomes water, water is more disordered compared to the ice. Okay? So when you put the solid sugar in water, the solution that form is more disordered than it is before, like the sugar and the water. So that's how they end up with this delta G. Now, in the delta G that you have here, okay, I think this is not the one. You have to memorize this table that they have here. So a negative delta H and a positive delta S, it gives you a spontaneous delta G, a negative value. A positive delta H, a positive delta S that will give you negative at lower temperature and positive at lower negative at higher temperature and positive at lower temperature. You have to look at that one there. Okay, and then a negative and a negative will give you negative at lower temperature and a positive at higher temperature. Then positive, negative, it's always what we call positive and then spontaneous. Okay. So question. I'm going to go over this one, but I'm going to put the link already for the next one, the module 6. Okay. So module 4 and module 5, that's your focus next week for the exam. So if we're going to look at the schedule, so we move a little bit, but it's fine. So if we follow the course guide, oh no, oh no, oh no, 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 oh no. Magal. So if you're going to look at this one, so the coverage of the one that we have is this module 4 and module 5. So module 4 is the types of the IMFA, and then we have the solids, liquids, and gases. Okay. So if I'm not mistaken, this is chapter 11 of my material, and this is 11 and chapter 5 of my material. And then the chemical thermodynamics, okay, so we're almost done, but I still have to do the phases. So this is chapter 6 and chapter 18 of my material, with some of the chapter 11 when we go to the phase changes. So that's the coverage of your exam 2. Now the coverage for exam 3 are all these. The chemical equilibria. That's all exam 3. So coverage doon sa what we call, I think we have already some exam of the IMFA. So we cover more on this what we call, maybe I'll give some other, because if I'm not mistaken, the coverage that we have for module 4 is just the IMFA. So maybe I can put some gas laws and some of the properties of the solids and liquids, and then we have the chemical thermodynamics. Thermodynamics. So dalawa yung quiz na ibibigay ko sa inyo, just to prepare you. Okay lang ba yun? Class, as I have told you, if you have any problem, the basic thing that you're going to do is to let me know. Okay? Because if you're going to